Right, have you ever had one of those days when everything goes wrong? Well, I'm having one of those months. Well, I haven't been able to get my hobby projects moving along because everything seems to be going wrong at the moment. It's been just bonkers, really. My fridge freezer went wrong. I'll just tell you the story anyway. My fridge freezer went wrong because it basically needed some more gas in it, because it's like, my dad got it in around 2004, 2005 I think it was. So as you can imagine, it's 2020, so I mean it's pretty old, and it's obviously had a very slow leak over many years, and it's not a significant leak. It's not the kind of leak that you have to go and find, because you can't find it because it's so small. So I had to order some R600A gas, which is isobutane, to sort the problem out. So this is where my problems all started, right? So I didn't have any money at the time, so my daughter ordered it for me, and she asked for it to be delivered to my address. Yeah, I was waiting for like a few days. Now they said it was going to be delivered on the 20th. What happens? Well, I thought I'll catch up with some sleep on the 19th, and then I'll be up bright and early on the 20th. Then I can be in and wake up for the postman. Well, the little twats went and tried to deliver it on the 19th, when I wasn't expecting it. So they sent a card through the door saying it was going to be left at the post office, which is more than a mile away, and because of my disability I can't walk that far at the moment because of my feet. It's like walking on rocks at the moment, and I don't have any transport. So we had to contact the post office, and they weren't very helpful. They were pretty useless. So so we ended up going up there. A friend took me up in his car. We got there, she said, "Oh, it must be still on the van." I said, "Well, we've got a car saying it will be here at the post office." "Oh, I'm sorry, it's not here at the moment. You have to come back later." Oh, I said, "Well, I can't just keep asking my friend to bring me up here every 5 minutes, just, you know, to see if the packages arrive." So we goes back home, and my friend wasn't very happy because he was having a bad day too. So we go back home, and then I contacted my daughter because she'd ordered it for me, because I was a bit broke at the time, so I had to pay back, you see. So she contacts the seller and asks for it to be re-delivered, and we waited, and we get a notification. She sent me a screenshot of the notification saying to be re-delivered, out for delivery, it says. So I waited and I waited and I waited all day. Again, nothing, absolutely no show. So we were getting rather peeved off at this point. This is like 5 days after when I was expecting it. So anyway, a whole week and 1 day has gone now, and I said, that's it, I've had enough. So basically the money that I paid her back, because I paid her back the money which she spent, she sent me £12 of that back to me, so that I can order it, so we can do it separately, right? So actually I missed a bit out. In between all this, I was getting so fed up. I discovered, after talking to a scientific friend of mine, a guy who works in laboratories and things, he said that actually you can use butane lighter gas. It's very similar. There's not a lot of difference. It's an inversion of the isobutane. It's still just as, you can use it anyway. So anyway, I got sick of waiting for the isobutane, so I used standard butane, and the fridge is working now. It complains a little bit. The compressor doesn't like it too much, but it works. It's fine. It's just as hazardous as isobutane. There's no real difference in that, but it works. It does the job. The fridge is working. It's cool. But I decided to stick a fan on it just in case, because so I stuck a temperature switch on there, so it switches the fan on to keep the compressor cool if a problem should occur, so it doesn't get above 60 degrees Celsius. But the maximum temperature you can really run a compressor at is 300 degrees Fahrenheit. I think that's about 100 and somewhat Celsius. Anyway, I forget the number now, but it's 300 Fahrenheit max. If it gets above 320, you're in trouble. Anyway, to cut a long story short, finally got my fridge freezer working. It's sorted. I've got the thermocouple switch on there, and then my microwave was acting up. I had a problem with that, and I had to fix the turntable on it. So I fixed the turntable on the microwave because somebody threw out an old microwave oven. So I was able to get the turntable motor, the synchronous motor out of that, and adapt it and fit it in my microwave, which is what it needed, a new synchronous motor. So I got that sorted out. And now we've come to this, which is my power supply, my FARNELL L30. It's type L30 stabilised voltage power supply. I'll just give you a view of the front. It's the original old model with the germanium transistors, which you've seen in all my videos when I've been doing testing, by FARNELL, and it uses germanium transistors. Now the problem is it's gone kaput on me. So I've got this thing apart, and I've been trying to figure out what the hell's wrong with the damn thing, because it was intermittently cutting out. Do you remember, if you watch previous videos, it had an intermittent fault where it would go off, and I'd have to flick the switches on the front and it would come back again. Well, it finally gave up the ghost. It's finally died on me, and I've been trying to figure out what the hell's going on. Now the problem I have, the main problem I have is that every schematic I've looked up on the internet, which is why I've had this on here, is for the L30D1 or the O2 series. That's the L30D. Oh, is it D1? Anyway, then there's the. Oh shit, that's upside down. We've got the L30D1, so that's that one, yeah, that's the one. And the L30-1, and then there's the L30-2. But you see, this power supply of mine is so old, it predates all of these schematics that I found on the internet. So I'm asking for help. If anybody out there has got this schematic for the germanium version, and I'll explain why. Because you might think there's not a great big difference, but this is for dual outputs. It's for extra high current. This has got all these output transistors. Mine's only got a single output transistor. Now you might think they're all the same, but they're not. The germanium version, all the resistor values are different because of the germanium transistors. Because silicon use a different biasing system. The germanium, all the germanium Zenas and the diodes are all different, and the denotations of the resistor positions are different. They're in different places. So whereas on here, on the schematic, it might mention Zenodiode 4, Zenodiode 3, Zenodiode 2, right? Zenodiode 1, there's Zenodiode 1, Zenodiode 2, Zenodiode 3, Zenodiode 4, but on mine, I've only got 3. I've got Zenodiode 1, I've got Zenodiode 2, I've got Zenodiode 4, but where's Zenodiode 3? I'd be looking all over and there isn't one. It only has, see if I can get you a better shot of this actually. It is upside down, I know. Now if we get some light on this, maybe you can see the board layout and you might be able to tell me if you've got one like it. Right, on my power, I've got the power connected to my inverter because I've been running tests and I like to do things safely. Right, I'll just take this clip off here. Now there's two power supplies. There's the main power supply which supplies output, the voltage output to the main transistors, which are down there mounted on the chassis, right? They're actually down there at the back with a big resistor that drops over, right? The voltage drop across the resistor is what determines the current. Right, so got it wired up so you can get a good view of it. Right. Now, one of the things that I know about germaniums is that germanium transistors and germanium diodes, specifically many transistors, is that they're very unstable because they leak, as in electrically they leak all the time because they destabilize. Unlike silicon, they're not stable. Over the many years, the reason why we don't have germanium microchips is because they're not stable. I mean, it was at the time when the microchip first came out that they went over to silicon, because silicon, that's why we all hear about silicon chips. We don't hear about we don't hear about germanium chips because there was no such thing. Germaniums are inherently unstable. They just always have been. Because what happens is that the base pin to the case often leaks through. Now, what's uncommon about germaniums is normally the case is not normally connected to the collector. It's normally isolated and it's normally screened. Some of the germanium transistors have 4 legs, so that they have what's called a screen leg, and that would go to ground. And on those particular ones you have to clip the screen leg off, because that's what causes short circuits when the germanium starts to go bad. So I'm just giving you a little bit of tips on this. Now, I'm starting to think, I've spent about 3 days trying to figure out what the hell's wrong with this, because at first I thought I had a bad transformer. I thought my transformer was wrong. All my voltages on the transformer are there. All the voltages to the bridge rectifier, the full wave bridge rectifier is there. All the voltages on, they've got 2 windings. That's the main winding for the power for the output stage. That's for that goes there. And this other winding here goes to these 2 diodes here. These 2 diodes supply a voltage to just drive the circuitry for the regulator circuitry, but not the output stage. Now, there's an imbalance in the circuitry because we're not getting enough minus faults. And I was trying to figure out what's going on. And it looks like, I'm starting to suspect that we have a leaky germanium diode. So what I'm going to be doing is, I'm going to be changing out, I'm going to take out MR4. It's marked on the board here as MR4. But when you look at the diagram, for anything that relates to MR, there isn't anything. We've got this end of diodes. We've got the D. We've got D6, D5. Might be better if I go around the back of the camera so you can see what I'm looking at. So I'm looking for MR4. No. You see, this schematic doesn't match, which is why I'm pulling my hair out over this, because a lot of it's same, a lot of it's well, I mean, I've got T2 and I've got T4, I've got a lot of it, but it seems to me that all the parts that I want are not on here, you see. I mean, my D5 and D6 is actually marked as MR2, and where's the other one? No, MR2 is 2 diodes basically, which is unusual. Normally you have MR2 and MR3, you'd mark each diode separately, but this says MR2, and it appears to be pointing at both these diodes, because these are actually where So actually where D5 and D6 should be, you see. And this is the input for the low voltage side to drive the circuitry, and we get a lot of Zener diodes for the voltage divider network. Now, it's starting to appear to me that that diode that I'm looking for, which isn't on this diagram, is my culprit for it possibly pulling the voltage down, and I suspect it is anyway, but it's not on here. But I have got those two diodes here. Right, there's two diodes back to back, which is on here, but these two diodes back to back are marked as D7 and D8. Right, these diodes are back to back, they're actually connected across the base of that PNP transistor there, which is VT2. So, I've turned this upside down, sorry again. So VT2 is that's VT1, that's VT5, that's VT4, that's VT3. Where the frack is VT2? See, that's another thing. Oh, hang on, there's VT2. Right, so VT2 is right at the top there, right, and it's a black transistor, so that's why it's hard to see it. Unlike the shiny candle ones, and that's a black one as well. But so VT2 is up there. Right, this is why I'm going nuts, because I'm looking at a diagram that is not for this board. So I want the old one that looks like this particular unit, the circuit diagram, and I've been looking everywhere and I can't find it. It's driving me bonkers. Because this must have been the very earliest. This must have been the very basic prototype that FARNELL brought out. It's probably the original one that they brought out before they went over to the Mark II, the LT1, yeah. So anyway, I printed, there's a whole bunch of them, I'll keep them up on the internet, but it says LT30-1, and I did find some later revisions, but I didn't bother to print them out because they're even more. They've got microchips, op amps, and this doesn't have any microchips. It's mostly germanium. And I took one of the resistors, the capacitors that were there, which was this one. So I thought I had a leaked capacitor. So this capacitor was actually where this one is. Was there. I suspect it might be leaky because the voltage across this capacitor is about 1 volt. It shouldn't be 1 volt. This is rated up to 50 volts. So there's a lot of voltage disappearing somewhere. I keep dropping this damn thing. It's hooked on somewhere now. So I took this thing out, put that one in, thinking that it might have been leaky, and it's not. There's nothing wrong with that. So I'm going to stick that back in later. So I stuck that value is 25 microfarad at 50 volts. So instead of which is a rather odd number, instead of having a 25 microfarad, I put a 30. I don't know what it is now. I think I put a 47 in or something. But it's just a power supply capacitor anyway. But it's still really 1 volt. So it's not a capacitor, it's a fault. Because somewhere my power is being bled away. I've got power dissipated somewhere, but nothing's getting hot. Absolutely nothing is getting hot. I've got the voltages coming in, but they're actually low voltages than what's on the diagram. But that's to expect because this is a revision. This is a silicon. This diagram here is for the silicon version, whereas this is germanium. So it makes sense that they use low voltage for germanium. And this power supply is rated between 0 and 500 milliamps. Well, it actually goes up to 600 milliamps, so a bit higher than that, but the scale on it, maximum is 600 milliamps. So this is 0 to 30 volts. So anybody out there that has the diagram, please put it on YouTube or something. Yeah. So I printed out this is the tracks on the other side of the board. So what I did was I took a photograph, get this lined up right, of the traces on the back of the board so I could flip it and look and invert. This is inverted, so what you see on here is you see the components on that side. So that's this is the circuit. So that's the copper track side, and that is the component side. So you can, I made it a little bit opaque because I was going to try and interface it, overlap it, but I thought no, I'll just do it this way. I can just flip that over to see where those connections. For example, if I want to know where that resistor is connected, I just flip that down. I can see it's there. Oh, it's actually there. Right. There's a link there. The link goes between there and there. That's that one. And that transistor 325 is right there. So I've been doing this to try and figure all this out, because it's a lot easier than moving the board around, because every time you move the board around and flip it up and down, you're breaking wires down here and wires start falling off. So I'm doing it this way. It makes life a lot easier and I don't stress the board out. So this didn't come out so well. I couldn't read the diode values, so I stuck a wiggly line out to indicate that that's a Zener diode, because it's confusing. And I put little rings on the board so I could see where the transistors were, because that's what I was focusing my attention on. But now I'm starting to think it's that diode Z4. No, not Z4, sorry. No, MR4. MR4 is what I'm suspecting now, because I've already had Zener 4 out and it made no difference. I put a different Zener in there, made no difference. So yeah, oh yeah, there's the other diagram. Oh, that's the one I was just looking at. Yeah, I did print out another diagram somewhere. I can't find it now. So anyway, I'm not going to bore you with the process of me unsoldering the. I did make a modification, put a different trim pot in here. I 3D printed a little bracket to hold it for the gate for the current limiting. So this is the board. This is why I don't like flipping it over, but because the wires are a bit restrictive. But you can see the board there. It's hard to see it, but you saw the printout one I did. So yeah, so what I've got to do, I've got to lift it up anyway. I've got to take this diode out here, because I'm saying I'm going to take it out now while I'm at it. I've got photos, so I won't forget where anything goes, because I've got photos of it. It's just been very frustrating, because it's one thing after another that's been going on. Oh yeah, did I tell you? Oh no, I didn't tell you. I was sat on my doorstep. I thought I'm going to sit outside and just chill out and rest for a bit. And everything's been going wrong. And I thought I'm just going to go outside, sit on my doorstep, and have a cigarette and relax. And what happens? Some guy breaks down on outside my freaking house. He's trying to start his car up, and he can't get his car started. And I'm thinking, oh, that's the start. This is my month, isn't it? It's not just me. Other people are having a bad day too. The guy couldn't get his car started, so I didn't even have my slippers on, and I walked down to the footpath, and I said, are you alright? And he says, oh, I can't get the battery's flat. Oh, I said, I've got some supercapacitors. He says, why, what's them? You never heard of supercapacitors? He says, no. I said, oh well, basically if I charge up my supercapacitors, it'll be enough to give your battery a kickstart so you can get your car started. And he said, oh right. I said, well, come with me, I'll go and charge them up and we'll see if we can get your engine started up. So anyway, so it comes up to my house, so I charge up the supercapacitors. I goes down, well, I couldn't charge them up because my power supply was completely kaput on me. So I had to take some batteries with me. So I took some 16 volt lithium batteries down, charged up the supercapacitors, and I was just about to connect them to his battery when I accidentally shorted the leads together and boom, bang. Yeah, so I discharged my supercapacitor, started to charge the batteries back up again, so I connected it back up to the lithium battery. We got them all charged up and hooked it up to the battery, and what I noticed was that his ground terminal was floating around. It was loose. I said, well, you need to get that sorted out. I said, no wonder your battery's flat if it's not connected properly. Your power's not going in there. Yeah, you can't even draw any current out of it either. So there's no wonder your battery's flat. He said, oh, right. He said, well, I tried to get the screw out, but it won't come out. It's stuck. I thought, well, that's no big deal. I mean, just cut the damn nut and bolt off and go and get another nut and bolt. Anyway, I asked him, I corrected it. I said, where's your best ground? Because this turble's loose on your battery. He said, I'll just clip it on here, which was the chassis. And I thought, well, actually, that's probably a bad idea. The resistance of steel is pretty high. You need to be pretty close to the copper, you know, when you're using supercapacitors to start your car. You need to be very close to the copper, yeah, not to the steel. Anyway, I clipped on the car bodywork, because he said, oh, clip it on here. So I did. I just clipped it on the car bodywork. And I said, try it now. He just went, bleh, bleh, and that was it. It wouldn't start. So supercapacitors were discharged. And I said, yeah, well, that's not going to work. So he said, well, I've got a mate coming down in a bit. I said, right. And he said, I'm just waiting for my mate to show up, and then he's going to give me a lift or something. He's going to give me a jump start it, whatever. I thought, all right. Anyway, so I charged my supercapacitors up again. I thought, well, I'm going to get this on this battery if it kills me. So I've got the clips on the battery. And I said, give it another shot, give it another go. Turns the key, starts straight away. And I thought the only reason it probably started straight away is because I'd clamped between the lead part of the battery and the loose clip on his battery clamp. No, it wasn't so much my supercapacitors that actually got it started as much as closing that loose connection on his battery. Anyway, I didn't argue with it. I thought, well, I've had enough of this. I just said, well, you need to buy some supercapacitors. They'll save you bacon. They're good for weak batteries as well. And he said, oh, thanks, mate, whatever. Yeah. So anyway, so Joe, I said to his girlfriend in the back of the car, I said, whatever you do, don't turn the engine off. Don't turn the engine off, will you? She said, don't worry, I won't. So he drives off, and that was it. So this has been my month. Everything. I mean, if it's not me, it's somebody else. And I don't even look outside right now. I mean, airplanes might start falling out of the sky. You know? Yeah. So there's always something. Anyway, so I'm gonna get that germanium diode. They're pretty fragile, these things, because they're actually made out of glass, you know. But right, so I'm going to have to tin one end of that and I solder gun. If I can find it, which one is it? Right, it's right there. I haven't actually had this out, so I can tell I haven't soldered it. So I'm just soldering one end of the diode. And I'm going to actually I'm just going to solder socket. Oh, that was a clean one. Straight away I got it. You've got to be quick with germanium diodes because the heat from your soldering iron destroys them. Trust me, the germanium diodes can't take heat for more than a few seconds. I have got a relatively low temperature. Oh, look at that, it comes straight out. So I've got the diode out. What I'm going to do is I'm going to measure. I've just got one end of the leg out. So what I'm actually going to do is I'm going to check that on my diode test first. On my meter, which is off camera. Move the mouse out of the way. Right, you should be able to see flipping reflections again. I don't believe it. Right, just tilt it over there. That should work. Right, maybe you can see it now. Right, I'm going to test it on diode test first. But even if it says it's okay, I don't trust it. I'm going to swap it out and put it. I've got some germanium diodes, so I can easily put another one in. I've got 0.287 on there, and the other way around we have nothing. Right, it's got a red band on it, this germanium diode, but I've got some germanium diodes and I'm going to swap it out and put I'm just going to take the damn thing out because at some point you've got to start putting in new components, because you don't know what's really bad, but it says it's alright, but I don't care. I'm just going to take the damn thing out. Oh, I need to get some more solder on the other end. I think I just heard it move. Right, I've got that out. There's the germanium diode. I'll just take out. I've got some green banded ones. I'm going to stick a green band in. Right, the hole's clear, that's good. Germanium diodes. If you look on eBay to buy a germanium diode, they're friggin' expensive. Bloody hell. They're not cheap. That's why I'm going to solder this one in with long legs, because if I want to take it out and reuse it, I can still do that. I'm going to leave it on an elevated leg, because these things are not cheap, and it will preserve its they're easy to fracture the glass envelope on them as well. You've got to be very careful with them. So I'm going to leave it on long legs, because then if I need to take it out, I will still have something usable from my prototyping board. I'm only working at 270 Celsius actually. I can come down a bit. I'll come down to 250. There we go. Right, I've got a new diode put in, but it's probably not going to make any difference. And now look, as I say, everything's been going wrong, so I can't trust even the fact that this is going to solve anything. I'm just going to trim off that excess leg. I can't remember how much they were, but I think they were like £5 or something for one diode, which is really crazy. These are OA90s, by the way, that's sticking in there. They were common in their day, very common, but not so much now. That's probably why they're so expensive. They actually become unstable over time, but mainly because they're in use. If they're not in use, even if they're not in use, they'll corrode. They actually corrode. I'm just going to unplug the solder now, because I don't want to have an accident with it. Alright, so I've got the diode. It's on elevated legs. You know what, I think I put it backwards. Oh no! I put it backwards. Oops. I put it backwards. I told you, it's just not my month. It's not, I could have plugged it in before I even realised, which would have been bad as well. I don't believe it. Well, at least I've left the legs long so I can just pull it out. You know why? It's because I had the board upside down before. I was looking at the board the other way up, and that's why I have it upside down, the wrong way around. There's no markings on the board about the direction to put it. Right, let's get it in the right way around. This right way round this time. It's marked, actually. It does mark the cathode. I should have seen that. And I've got bad eyes as well, so yeah. Have I got a blocked hole? No, I should go in there. Oh yeah, I've got a blocked hole, hang on. Smell it. There we go, it's in. Alright, soldering good enough. I'll do a proper job though, because I just burnt my finger. I like this soldering. I'll tell you why, I'll explain it in a minute. The heating element on these TS100s is right on the end, so you can touch the stem at this end and you only get a mild burn. If you touch that part, you get a serious burn, but it gets hotter as it goes near the end. Unlike conventional soldering irons, they have an element that goes all the way along. Well, anyway, these particular types of soldering iron are just do good. You're less likely to burn your finger, because if you actually put your finger on the back end here, it's just a mild heat. It's not red hot like some soldering irons. Yeah, I could have burnt myself pretty badly, but I didn't. So I just caught it with my finger. Right, let's see now. I've got to put my inverter on because I want to see if there's anything worthwhile to see. So I'm going to stick this like that. So you can see the meter. I'm just going to put the inverter on. I'm running it off inverter because it's not full mains and it's safer to work on. Right. It's at 220 instead of 240 as well. Right. No different. We've got a little bit of movement on there, but no. Still not working. So I know it's not it's not the diode, but it's like the current limiting is on permanently. That's what it is. It's like the current limiting is on permanently, but it's not coming current limiting. So there's a problem there. It's probably a leaky germanium somewhere. I've been checking voltages, and the voltages just seem to be a little bit low, but that could be because I need to pop that meter up on somewhere. Actually, if I put the meter on this side, it should be easy to see it. Maybe. Right. Now let's see what I mean. The voltage on the main regulator side coming in, the total voltage is is 25 when I've got the switch on the mid-range setting. That's 10 to 20 volts. If I go to the 20 to 30 volt range, then the voltage across the diodes is 36.2. Right. I'll leave it on the mid-range though for the testing stuff. The voltage on the low rectifier side, which is over here, you can measure across this capacitor here, which is 35.7 volts. So 35.7 for these two rectifiers. So we've got voltage present. We've got, this is the secondary voltage, this is the primary voltage. Right. The primary voltage is only going to the output stages. This capacitor is what is taking the voltage from these two diodes. So if I go to this is a Zener diode, this big metal thing here. 21 volts on that. 35 on that side. $20 volts on that resistor. That's weird, what's going on here? At the moment I've got nothing coming out of the other end of this resistor. What if my resistor's bad? It says 1.2k. There should be something coming out of here. What if my resistor's bad? Let's check across this Zener. The Zener is got 5.3 volts across that Zener there. This Zener diode is got 22.7 volts across it. This one. That diode I've just replaced. There's 4.3 volts across that diode. Right. Let's check this voltage. This was about 1 volt across here before. What's it now? Oh, we've got 1.8 volts across there now. That seems to be a bit better actually. 1.8 volts, mind you. Let me see, what is it? Is it because I'm on this higher setting? Let's go to the lower setting. 1.4 volts across it now. So yeah, it does seem a bit better with that other diode in. Is that diode getting warm? No, not really. Yeah. Anyway, as I said, there's no point in me continuing this live stream because I've been working on this for 3 freaking days, and there's no way I'm going to figure it out now straight away because the voltages on the input are there. This is a 100 ohm resistor and we've got a voltage across it of 1.2 volts. That doesn't make sense. We should have more than 1.2 volts across this 100 ohm power resistor. I mean, yeah, there's something seriously wrong here. That's a 560 ohm resistor there. We have nothing across there. 560 ohm resistor, we have absolutely no volts at all across that resistor. Let's go to millivolts. Millivolt range, we have 65.8 millivolts across that 560 ohm resistor. That doesn't make any sense. It just doesn't make any sense whatsoever. There should be a lot more power going for that resistor and there was nothing at all. And this is the driver section, bear in mind, the current limiting section, so there's something seriously wrong somewhere. Yeah, I've got a leaky transistor, I suspect, but I have changed that one. I swapped that one out. This one here, this big one. I also changed that one, which was a BC 547. I stuck a BC, no, it was a BC 547. I stuck a BC 546 in there, which is they're actually the same. There's not much difference. Yeah, I'm being scratching my head because I'm working with a diagram that is not the right diagram. And when you start reading a diagram which is not the right one, and it's got all the resistor values are different, and most of the markings are in a different place. It just confuses the shit out of you. You just can't make head or tails of it. You're just completely confused because it's leading you in the wrong path, we see. And there's components on the diagram which are not in here, and there's components on here which are not in the diagram. So yeah, this is why I'm asking if anybody out there happens to have the L30, the FARNELL stabilised voltage supply type L30 with no after scores after it. No, it's L30, the original L30, the one that came out before all the subsequent modifications and upgrades and everything else, because this is mostly germanium transistors in it. It's a PNP circuit mainly. Even the output stage is PNP instead of NPN. There's no NPNs in it. Well, there's a few NPNs in it, but most of them are PNP. Yeah. And the voltage on this capacitor is not, because, well, this is the output capacitor anyway, so if we go to measure the voltage on this capacitor, we probably get, we've got 1.2 volts on the output capacitor, which is ridiculous, because I've got the trimmer pot, the output stage is maxed out now. We should have at least 10 volts on here, and we have 1.26 on it. Right now we have 1.11, so there's something, yeah, seriously wrong, and I'm going nuts with it actually, to be honest with you. Anyway, I'm going to end the stream. I'm going to drink some coffee and eat some shortbreads, some Scottish shortbread fingers, Highland speciality things, and that's how I mean Berto off again, because so the voltages are just out of whack somewhere, and I can't figure out why. It's not, I'm getting too old for this sort of thing, I really am. I mean, I can work out all sorts of stuff, but this thing confuses it. It's because of all these frigging wires on this side. There's a whole bunch of wires that go to the transformer, and a lot of these wires actually go to the front panel for the divider network on the switch. When you turn the switch, it switches some resistors in circuit on here, and I've checked the resistors, they seem to be okay. And it can't be them anyway, because otherwise it would work on one setting and not on the other, whereas it's not working at all generally on any setting. So it can't be the front panel switches, because they're just set different modes of operation. I know it's the current limiting circuit that's got the problem. It's this area down here, around here, this section. This is where the problem is, somewhere. And I just haven't tracked it down yet, so I'm thinking about pulling a lot of these resistors out, one end of the resistors, pulling out the legs at one end, all of them. I'm just going to pull all of the resistors out by one end, so I can isolate everything, so I can start checking things, checking resistors, checking transistors, without pulling all the transistors out. It's a lot easier just to pull one leg of a resistor out, isolate the transistors, then you can start to diagnose what's going wrong more effectively. So that's the next plan, and I'll be desoldering some resistor legs. I'll be using my little hook thing to grab the resistor, because these are big resistors, you can easily grab the resistor legs and just pull the legs out one by one on one end, leave the other end in, but just pull each end of the leg out. That's the next plan of action, because then I can start to diagnose things more effectively. There's not that many resistors in here, to be honest with you. There's what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, I think about 17, 18 resistors. Anyway, there's not that many, but there's some trim pots as well. So yeah, thought I'd give you an update on what's going on with my life right now. I just need to fix my life. So I suppose I can show you the diagram. Just give me a sec, let me just... This is the diagram I'm working off, I don't get it up. Right, let me just switch over to give me a sec. Right, I'm just going to show the diagram. There's the diagram. Right, that's what I'm going to end with. So that's what I'm working from, but as I say, this diagram isn't the right one. There are other diagrams on the internet. This is the closest one I could find. See, down here at the bottom, if I zoom in a minute, I should be able to see this. If I zoom in, I'll turn my keyboard off, haven't I? Right, if I zoom in down there, it says LT30-1 /1 supply 2. Well, this is for a dual supply unit. Mine's the LT30 without any aftermarks on it. You know, that's it basically. So that's the diagram. I'll zoom in and pan around a bit so you can get a closer shot of it, because it's probably not very intelligible. So let's move across. This is the two diodes for the secondary power supply. That's the main power supply up there. The rectifier circuit, and the current limiting circuit is around here somewhere. I don't have an overload indicator, I don't have an LED in there, so this is insignificant. T1 is in there in mine, but I've got VT2, VT1, I've got these diodes here, but they're marked differently. I don't have all these VTs after, you know, I just have, I think I've got VT, I've got VT1, I've got VT1, VT2, I've got VT5, I've got VT4, I've got VT3, that's the voltage, apart from the stuff that's mounted on the chassis, which is possibly these two, VT6 and VT7, but I'm not using the 2N3055s. Mine are just the different packages. They're like the TIP 42 package types, you know, those types. I've forgotten the type that actually package type now, right, so yeah. Anyway, if you can help out, just comment, send me a comment if you happen to have the diagram for this thing, and email, I'll give you my email or something, and yeah. I suppose I could contact FARNELL Instruments actually, they'll probably have the original circuit diagram for this. That's possibly an option. I did used to have an account with them years ago. When I was self-employed. Anyway, that's it. I'm going, gone.